Problem number 10 is asking you to find the length of the path over the given interval. Now it gives you e to the t plus e to the negative t as your x of t coordinate, and it gives you 5 minus 2t as your y of t coordinate. And it also gives you an interval between 0 and 1. So when it asks for the length of a curve, it usually wants arc length. So let's go ahead and apply the arc length formula, which I've written up here. That says that L is equal to a to b, where a and b are your given interval numbers, square root of dx dt squared, the derivative of x with respect to t, and dy dt, the derivative of y with respect to t. All underneath a square root with a dt outside. So let's go ahead and let's plug into this formula. So my a and b, I already know that's 0 and 1, and the interval is usually given to you, so you just need to find it in the problem. Dx dt is equal to, so when I go ahead and write this out, I get e to the t minus e to the negative t, quantity squared, plus 5 minus 2t, the derivative of that with respect to t is negative 2, so I end up getting 4. Now when I go ahead and factor this out, there's no way to really reduce this down. Again, I'm trying to figure out a way to integrate this equation, and right now I don't see anything. So what I'm going to do is I'm going to factor out this term and see if I can simplify it somehow. So I end up getting e to the t squared, which if I take a power to another power, I multiply those powers together. My middle terms become e times negative e to the negative t, so they become minus e to the t, e to the negative t. And then there's also another term in there, e to the t, e to the negative t. So first, outer, inner, and now the last term will be plus e to the negative 2t. And then I have my plus 4 outside here, or inside rather. So now I can go ahead and I can simplify these terms. So this is equal to the square root e to the 2t. This is e to the t times e to the negative t. I add those powers together because they're multiplied by the same base. So that becomes e to the 0, which is 1. So this is also 1, so I have a minus 2 plus e to the negative 2t plus 4 dt. So what I'm going to do is I'm going to go ahead and I'm going to add these terms together. I have a plus 4 and a minus 2. So in the middle here, I should get a plus 2. So now I just need to figure out a way to simplify this. So right off the bat, it doesn't seem like there's anything that really simplifies this, but I noticed that there's an e to the 2t here and an e to the negative 2t here. So it looks like maybe I can make a perfect square out of this. So if I go ahead and try to reduce that down, what I end up getting is I actually end up getting integral from 0 to 1 e to the t plus e to the negative t quantity squared. And if I go ahead and I refactor that back out, I should get right back here, which I do. So therefore, this term is actually a perfect square. So you have to condense that down and reduce it into that form. Now, what I'm doing is I'm taking the square root of a whole entire square term. So I can just go ahead and simplify that out. And I end up getting e to the t plus e to the negative t dt. So now all I'm integrating is I'm integrating e to the t plus e to the negative t, which I can do. So let's go ahead and apply that integration. Let's see what we get. So this is equal to 0 to 1. Well, actually, I'm going to go ahead and integrate that. So let's just go ahead and apply the integration step. So I have e to the t. The integral of e to the negative t is minus e to the negative t. And that's evaluated from 0 to 1. So when I go ahead and I plug that in, I end up getting e to the 1 minus e to the negative 1 minus e to the 0, which is 1, minus e to the 0, which is 1. So that term is just 0 at the very end. So my final answer is e minus e to the negative 1. And this is also to a first power. So that would tell me that my final answer should be E on exam 3B.
The Teaching Center, UF's Learning Resource Center.